We shall see the next problem on star delta transformation. Find the equivalent resistance between the terminals A and B. So the network is given. Now observe the network. This network you may find little difficult to analyze because the connection will look little complicated. So first let us redraw the circuit in such a way that it will make us to look in still more simpler way. So for that let us now redraw the circuit. So if you observe here, the connection here is from this point to this point. So we shall take this connection instead of which is present inside to the outside of the network. When you write the circuit, you'll get like this. Redrawing the circuit. So I have now redrawn this circuit. This part is now written like this. You can observe I have just taken that branch and I have written that like this. That's all. If you observe the network, you have two delta circuits here. You can form one, you can take out one delta network. This is one delta network. Draw one star network within the delta network. Name that as R1, R2 and R3. In the next circuit, let us replace the delta network with the star network. So the circuit will now look like this. I'm keeping the same circuit, but only the delta network I'm now replacing with star network, and resistances I'm taking as R1, R2 and R3, and remaining values you just write as it is. This is 15 ohms, 45 ohms, 30 ohm and 40 ohm. Now find out the values of R1, R2 and R3 by using delta to star transformation. So this is R1 resistance. This will be equal to 20 into 35 divided by 20 plus 35 plus 25. 20 into 35 divided by 20 plus 35 plus 25. You will get 8.75 ohms. Similarly, this is R2, 20 into 25 divided by 20 plus 25 plus 35. 20 into 25 divided by 20 plus same. Denominator remains same, which is equal to, you will get 6.25 ohms. R3, which is equal to, this is R3, 35 into 25 divided by 20 plus 25 plus 35. 35 into 25 divided by 20 plus 35 plus 25. You will get 10.94 ohms. Now write those resistance values. R1 you got 8.75 ohms, R2 you got 6.25 ohms, and R3 you got 10.94 ohms. Now again let us redraw this circuit. Redraw the above circuit so that it will look in simpler way. I will mark this as C node, this as D node, and this as E node, some dummy nodes. Now in the same way, if you write the network, if you observe A to C, you have 15 ohms. So A to C, I have 15 ohms. This is C. And C to D, if you observe, you have 6.25 ohm. The same resistance I will write here, 6.25 ohms. This is terminal D. And D to E, if you observe, you have 10.94 and also 40 ohm, which both are in series. If you observe, these two will make a series combination. Similarly, these two will also make a series combination. Let us mark this as B to E. I have taken here B. So this is B, B to E. Okay. Now if you observe C to E, you have 45 ohms. I will write in the same way, 45 ohms. And D to E, if you observe, there is 10.94 ohm and 40 ohm which are in series. So I will write like this itself, 10.94 ohms and 40 ohms. And again you have from D to E, same, from D to E you have 8.75 ohm and 30 ohm which are in series. So this is D to E. I will be taking both which are in series resistances, that is 8.75 ohm and 30 ohm. Okay. Now you can look at the circuit. It is even more simpler. So these two will be now in series. Add the resistances, 8.75 plus 30. You will get 38.75 ohms. And next these two are in series. 10 plus 94 plus 40, 10.94 plus 40, you will get 50.94 ohms. After reducing the series combination, you will write the remaining circuit. 15 ohms, 45 ohms, 6.25 ohm, 50.94 ohms, and 38.75 ohms. Okay. Now if you observe the circuit again, these two becomes parallel connection. So in parallel it will be 50 into 50.94 into 38.75 divided by 50 plus 50.94 plus 38.75. So you will get 22.01 ohm. Now replace that. You will get the circuit like this. A 15 ohm, B. Now again here 6.25 and 22.01 will be in series connection. So add both the resistances 6.25 plus 22.01. You will get 28.26 ohms. Now again place the 28.26 ohms. 45 ohm, 28.26 ohms. Now if you observe, again these two becomes a parallel connection. So 45 into 28.26 divided by 45 plus 28.26. You will get 17.36 ohms. Now replace that 17.36 ohm in the circuit. 15 ohm, 17.36 ohms across terminals A and B. So if you observe here, it is just like this. A 15 ohms and 17.36 ohms, which makes a series connection. So both are in series now. So add the resistances 15 plus 17.36. You will get 32.36 ohm. So equivalent resistance across A and B is 32.36 ohms, or RAB, which is equal to 32.36 ohms. Next problem. Find the equivalent resistance between the terminals A and B using star delta transformation. So this is the circuit which is given. Observe the circuit. When you observe the circuit, you can find two T networks that is present. One is 5 ohm, 3 ohm and 4 ohm, and another one is 6 ohm, 4 ohm and 8 ohm. One network is 5 ohm, 3 ohm, 5 ohms, 3 ohms and 4 ohms. And another network is star network, 6 ohm, 4 ohm and 8 ohms. Now for this star network that you have identified from the circuit, build one delta network. Similarly, for this star network also, build one delta network. Name the resistances as R1, R2 and R3 here, and this you name as R4, R5 and R6. When you just replace the circuit, these two circuits again back, R3 and R6 will be in parallel, R1 and R4 will be in parallel, R2 and R5 will be in parallel. Now by using star to delta transformation, first we shall find out the values of R1, R2 and R3. R1 which is equal to numerator will be 5 into 3 plus 3 into 4 plus 4 into 5. 5 into 3 plus 3 into 4 plus 4 into 5 divided by R1 opposite resistance. Here it is 3 ohm. So divide it by 3. R1 you will get 15.67 ohms. Similarly R2, this is resistance R2. R2 which is equal to numerator is the same 3 into 4, 4 into 5, 5 into 3. Same right as it is. Divided by R2 opposite resistance is 5 ohm which is equal to 9.4 ohms. Similarly R3, this is resistance R3, 5 into 3, 3 into 4, 4 into 5 divided by R3 opposite resistance, that is 4. So divide numerator by 4 ohms. Divided by 4, we will get 11.75 ohms. In the same way, now you find out R4 and R5 for this network also. R4 will be equal to, R4 is this resistance, 6 into 4 plus 4 into 8 plus 8 into 6 divided by R4 opposite resistance is 4. You will get R4 26 ohms. R5, this is R5, same 6 into 4 plus 4 into 8 plus 8 into 6 plus 4 into 8 plus 8 into 6 divided by R5 opposite, that is 6. You will get answer 17.33 ohms. R6, numerator is same 6 into 4 plus 4 into 8 plus 8 into 6 divided by, this is R6, R6 opposite is 8. You will get 13 ohm. Now replace all these values or two delta networks in parallel combination. Now you will get across the terminals A and B, the circuit will be like this. This is R3 and R6. If you get confused, you can write like this. R3, R6, correct? R3, R6, R1, R4, R1, R4, R5, R2, R5, R2. Write the values. R3 is 13 ohm. Sorry, R3 is 11.75 ohms. R6 is 13 ohm. R1 is 15.67 ohms. R4 is 26 ohms. R2 is 9.4 ohm. R5 is 17.33 ohms. Okay. Now, if you observe, these two will form a parallel connection. So, answer will be 13 into 11.75 divided by 13 plus 11.75. Then You will get answer here as 6.17 ohms. Next, these two will form a parallel combination. So 15.67 into 26 divided by 15.67 plus 26, you will get 6.17 ohms. This parallel combination, if you observe, this is also parallel, but it becomes 0 because 9.4 ohm and also 17.33 ohm is in parallel with the short circuit. For short circuit, voltage will be equal to 0. So when you do a parallel combination with 0, obviously your answer will also be 0. So that's why this whole part will be just a short circuit replaced by V, which is equal to 0 now. When you rewrite the circuit, when you again write the circuit, reduced circuit, answer will be, circuit will look like this. 9.78 ohms. Sorry, this is 9.78. And one more resistance you found out which is in parallel, 6.17. And this will be just a short circuit. Okay. Now if you observe, again these two will become a parallel. Reduce that. 6.17 into 9.78 divided by 6.17 plus 9.78. You will get 3.78 ohms. So your final answer is R across terminal A and B, the resistance is 3.78 ohms, or RAB, which is equal to 3.78 ohms. So this point you have to remember here. If there is no a voltage V which is equal to 0, if this part is not present, then the answer would be different. Since you are connecting in parallel with a short circuit, so this will also become a short circuit. Sometimes across here in the circuit the resistance will be given. So concentrate and solve the problem.